Hello, everyone. I am Nagasaki from the Search Ad Development Unit at Line Yahoo Corporation. Today, we aim to eliminate the need to look at logs. This is achieved through automated log collection and AI-powered log understanding and decision-making support. I will speak on the topic Slack-centric alert operations. Today, it started with a keynote, and you've listened to about 6 minutes of the 30-minute session. From here, I hope you will enjoy two 15-minute short sessions. As the title suggests, I will be speaking about how we, on a daily basis, the exhaustion from system alerts that we had been struggling with, we dramatically improved it using CCAI. I will explain the reasons for that. I'm sure some of you listening now, I believe there are some of you who are tired of the alerts that sound during the night and on holidays, and of checking long error logs. Today, I would like to introduce an example of operational automation using AI that all of you can immediately emulate in your own teams starting tomorrow. Again, I am Toshiki Nagasaki from the Search Ad Development Unit. Currently, we are focusing on search-linked shopping ads, specifically search engine design. We are developing and operating. I have been in charge of the backend for about 6 years, around the search engines of EC and gourmet services, even on the train. Today, I will talk about what I have struggled with in system operations. I will be discussing how we improved operations by automating log collection and leveraging AI. First, I will explain why we decided to pursue such automation and AI utilization. It all started with a very from the field of practice. My team develops and operates the delivery system for search-linked shopping ads, as I just mentioned. The team we operate. A massive amount of logs flow through our systems every day. Since system uptime is directly linked to sales, it is important to detect status changes quickly. It is a crucial mission to keep it running for as long as possible. To ensure that critical system alerts are not overlooked, our team has been working on alert maintenance since the early stages of the service launch. This is an initiative where all team members check and share alert notifications that occurred from the previous night until the morning of the day. Through this alert maintenance, all members share knowledge of the system status and the alerts that occurred. Among these, if issues requiring additional investigation or action were found, we would assign a person responsible and a deadline, and then work to resolve the alerts. However, as the service grew, the number of notifications became enormous. The time for this alert meeting became longer and longer. There were days when we spent about 60 minutes a day on these alert details when they were long. As a result, team members were exhausted, and it was tough to keep monitoring alerts in this state during the New Year holidays. It was a very stressful situation. This is a log of the game with Sunday. By combining the log infrastructure API and AI, we dramatically improved the situation. That is the highlight of today's talk. For example, what kind of things happened? More and more decision-making for readiness and response is being completed on Slack. Additionally, thanks to the AI remembering past cases, even if we forget them, we can instantly recall them. In addition, even system messages that might seem difficult for new members at first glance are now quickly understood, thanks to AI summarizing and analyzing the logs, allowing them to catch up on occurring events. As a result, the alert meeting that I mentioned earlier, which used to take about 60 minutes, has now been shortened to approximately 10 minutes. Today, in this flow, we will explain how we have proceeded with improvements. Next, I will discuss how our alert operations have changed. First, in order to improve, I would like to reorganize what our alert response flow was like. This is how it generally flowed. First, we receive a Slack notification, and then humans manually open the log database. Then, from the vast amount of logs in the log database, we will we again manually find the relevant logs. Once the relevant logs are found, we analyze the extensive content and post the necessary information for response preparation and decision-making, as well as the response decision on Slack. If additional investigation or action was deemed necessary, A ticket would be created and assigned to the relevant person. That was the flow. Among these, what had a particularly high cognitive load and became a bottleneck it was two things: finding the relevant logs and interpreting them. To be more specific, the problem we faced with log searching was that the content notified on Slack after all, it was limited to simple information such as metrics, specifically the number of alerts generated, or fixed alert names. That's what it was. The specific messages were not known until we looked at the log database or accessed the server. Therefore, every time an alert sounds, a person has to take action. It was difficult to anticipate how to respond in such a state. Of course, our team tried to streamline our work, for example, by creating a shortcut link to search for error logs from the past 15 minutes. However, because the filtering condition is time-based, if confirmation was delayed, it would have been necessary to change the narrowing conditions. Furthermore, cross-referencing the alert titles with the corresponding logs manually was a very laborious task. Above all, investigating logs from a smartphone after working hours, especially when out and about, was quite a high-hurdle task. Another challenge is that it's tough to make sense of the vast system messages. Regarding this, a certain level of technical skill is required to decipher what is happening, where, and for what reason from stack traces that span tens of lines. In urgent situations, even skilled engineers find it difficult to make instant decisions. That can happen. In this way, in actual operational scenarios, not only general programming knowledge, but also knowledge specific to the product is required. For example, let's say the system timed out. Let's say such an error message appeared. Generally, I believe the urgency of the response is determined based on the log level, such as 1 or error. However, in actual practice, they inevitably occur due to releases and maintenance. In such cases, you can ignore it, I think it's not uncommon to have operations with implicit exceptions. By the time it reached this point, it was a state that could only be called a spell for new members. We considered 2 points then. The first one is, instead of humans going to look at logs, the logs come to us. The other one was, if reading logs is painful, why not have AI translate them? Specifically, this is the approach we took. First, let's have the logs come to us. Regarding this, we created a system that uses Slack notification messages as triggers to retrieve logs from a log database and automatically reply to Slack. This is obtained via an API, using an in-house PIS as a worker. Slack notifications. It starts immediately as a trigger, so even with the 15-minute filter I mentioned earlier, it can gather enough logs. Also, with the systemization, information is now collected more accurately and thoroughly than when it was manually collated. In addition, the acquired logs are passed to the LLM for analysis. AI extracts the severity of error content from lengthy logs. We instruct it to extract the frequency of occurrence, possible causes and scope of impact, and recommended actions, and then summarize them in an easy-to-understand format for humans. This has allowed us to quickly decipher truly necessary information from the logs. By automatically replying with error logs on Slack, we are now able to check the contents of the logs without having to transition from the Slack screen. This has eliminated the need to search for logs. It's as if we're glued to this alert channel. Alert occurrence immediately. It felt like we had hired a dedicated engineer who would edit the log content in the thread. And the AI's automated analysis results are also posted along with it. We can review the content with the ALR logs, severity, frequency, possible causes and impacts, and recommended actions, all organized as I just mentioned. Humans no longer need to painstakingly interpret complex system messages. This has significantly increased the speed of our situation assessment. By improving these two bottlenecks, the alert handling that I mentioned at the beginning, which used to take 30 to a maximum of 60 minutes, has been shortened to just 5 to 10 minutes. Above all, through the efforts mentioned, the psychological hurdle of checking alert content has been significantly reduced. Actually, we are proud to say that the biggest achievement of this initiative is that it has enabled us, as humans, to make decisions with confidence based on the evidence presented by this AI, rather than simply saving time. So far, I've spoken as if everything went smoothly just by introducing AI, but when we actually started using it, there were some rather messy parts. It wasn't a one-and-done solution, it was merely the beginning of trial and error. Also, because we couldn't solve everything with just pretty words, I'll talk about the tuning we undertook later. Regarding the first point, it means that AI also needed onboarding. I think you've heard many times in today's sessions that context is important for AI to answer correctly. This naturally applies to alert response as well. An AI without any knowledge can only provide generic answers. Regarding the urgency of the response, we can only make a simple judgment. If it's an error, immediate action. If it's a warning, observe and monitor. However, in a test environment, there might be cases where errors are intentionally generated for temporary operational checks. Taking into account the actual circumstances on site and responding to errors is indispensable in the context of products and actual operations. These stories are not limited to AI. They are the same for us humans. So what we thought was to incorporate metadata, such as past cases and environmental information, into the AI prompt and convey it. This has enabled the AI to make flexible decisions. What we've devised here isn't just about incorporating past response records and procedure manuals into the prompt. This means that information such as operational rules and system maintenance information is also being input. For example, this error in the QA environment this is a known issue and we are currently addressing it, so immediate action is not required. We include messages like these. Then, the AI makes judgments similar to ours, determining whether it's an unknown critical error or an error that has been recovered from. We input links to tickets scheduled for resolution and maintenance notification threads into the AI, and it includes those in its replies. We are now able to recall the context immediately and make confident decisions. Generally, if an alert doesn't require action, you might think it shouldn't be notified in the first place. However, in reality, it may not always be possible to immediately delete all unnecessary notifications. Or perhaps there are unavoidable alert messages that occur within a scope beyond our control. This is where we, as a team, have been working hard to cover the operations. Nowadays, AI can take on this role. Also, instead of leaving everything to AI, we strive to improve the user experience by incorporating rule-based approaches. For example, frequently used Slack stamps, such as observe or requires action, are automatically replied to in the thread. Now, people only need to press a stamp. In addition, by extracting important keywords contained in error messages and stamping them, we can now quickly understand the content of alerts without having to open the thread. I will now introduce an example of a case where we were actually able to detect an anomaly by introducing such an alert bot. In our system, we connect with components from other teams. However, a validation error occurred, indicating that the linked value was outside the expected range. Because our alert bot, which is close to our judgment level, told us this is an unknown error, we were able to inquire immediately and notice the error before the production release. Finally, I'd like to introduce the lessons learned from this initiative. One is to start small and expand gradually. Instead of insisting on integrating AI from the beginning, why not start by having the logs automatically reply to Slack? If you start small, you will gradually see what you want to utilize with AI. The second is to prioritize the user experience. As with the Slack stamps I mentioned earlier, without sticking to AI, humans, we believe that resolving the biggest bottleneck this time has been effective. The third point is that prompts need to be nurtured. It's not a one-and-done creation. By changing daily cases, systems, and team judgment criteria, and by conveying these to the AI, it becomes capable of making decisions that are more aligned with ours. What I talked about this time, regarding the content, we didn't build an especially large system. The important thing is to start small. We encourage all your teams to consider introducing an AI partner, if you will, to help make daily operations easier starting tomorrow. This concludes my presentation. Thank you for your attention.